Quite a few years ago I learned a really good lesson about being accurate right from the beginning, and as we've progressed in our learning about soil and how we can grow soil, it's been really important to actually how we document that progress now. And as I'll show you through this video, the changes that can come about really fast, and what needs to happen if you're really serious about this process is to actually take samples right at the beginning, because otherwise you won't have a baseline, and without a baseline anybody can make assumptions about a whole lot of stuff. So what we're finding, I'm going to give you a real example of what you can and should do if you want a good baseline, know what's going on and how to actually increase the carbon in your soil. I mean, not only are we increasing carbon, but we're increasing production. So what I'm utilizing here is I'm standing in the middle of one of our trial plots where we've 1 year ahead in trials compared to outside of it, and I'll show you the difference in the soil visibly, and you can see how we log it, plot it, measure it and send it away for testing, and then we can calculate how much carbon's there, how much total nutrient. Really important stuff. Really good information to know where you're going to on your farm, because you've got all this info that you can actually take really good heed of and calculate where you need to go to from there. So what we'll do is that we'll get down and have a look at this here. And so this is a couple of plugs I've already taken. Now notice I've got the GPS there already, so I've GPS plotted it. I'll take a photograph of it and we will split it into the profile. So each profile, the top profile gets cut into 150 mils, the next profile down into another 150, so we're going down to 300 mils. Although when you look at the issues that we're dealing with now, I think before long we're going to have to start looking at going a lot deeper, so I'll have to take some of my own advice. Now if you look at the top sample, that's had 1 more year's preparation, really, applications of material that we've got the soil to start growing, and as you can see it has actually got really extensive. Like, we started off with the soil up here and this was all really red soil, so within a 3-year period, from what we've discovered, we've actually taken that red soil and we've now gone right to the bottom of the plug and it's off the end. So when we test these, what we have to do is that we have to split them into 150 mil plot cuts, because that's what the laboratory calculations are based on. So you split it there and you split it there, and so that sample there, that'll go off, get us a total soil sample, and that one there, they want to get us a bulk density and a carbon sample. So that way what happens is that this topsoil, which we look at the total amount of nutrient, the carbon, bulk density, and we can calculate what needs to be done. We can see what's going on with the issues about toxicities, mineral deficiencies, lack of biological activity. But while we do this, by doing a bulk density that shows the size of the soil or the weight of the soil per cubic meter, and so that can be calculated up per hectare. And when you do a carbon test, a full carbon test in that level, it can calculate with the bulk density and tell you exactly how much carbon you've got in a hectare. So with the GPS, with us marking it, every sample we take, it's really important, because we want to know exactly where you are. Now the test that we did before, you've got to notice that we were only 10 meters away outside of the plot to get this sample, so that's why accuracy really comes into it. So the second 150 that we do, we just do a bulk density and a carbon test, so we know how much carbon we have in the top 300 mils of our soil. Although, as I say, we may have to start testing a bit deeper now, because we're watching this carbon go so much deeper so quickly. So if you can consider there's approximately $10,000 worth of carbon per hectare in the top 6 inches of that soil as it is now, you can imagine if you actually get it down to the 150 like we had in the other plot, we're looking at adding another $10,000. Now that only took us 3 years, and we look to be starting to extend even further. And this is something that we're not just seeing on this property, we're seeing it on a lot of properties that we're been working on, and it's really quite invigorating to actually see the changes. But I mean, that's the carbon in the soil biology and everything's one part of it, but what we're seeing too is the growth and the production changes that come with it. So accuracy is absolutely paramount in this game, and by doing it, getting the right soil samples done, getting them calculated up, and that's something that we've developed at Ecofarm Aotearoa because we knew we damn well had to, because no one else is doing this, and who was going to actually believe us if we were doing all this stuff and showing how much carbon we were increasing, because it's way more than what most people can even dream of the increase in carbon and available nutrient in the soil. So you can imagine the water holding capacity, plant production abilities. It's pretty cool what's going on, and yeah, we need to get it out there. The information's available.